All right, guys. So I'm going to go over this worksheet that's due today, and then I'll talk a little bit more about percents. But really, tomorrow when we meet tomorrow morning, I'll go over the percent comp worksheet and then talk more about percents and percent hydrates. So I'll intro that a little bit today. We'll see how long this video takes. Shouldn't take too long. All right. So let me zoom in, or actually, yeah, let me do this. All right, so I should be able to do all four here if I just take a picture of that. All right, here we go. So, okay. All right, and we'll go with orange here today. All right, so part A, using this equation here, how many moles of silver, that's Ag, are needed to react with 40 moles, this is nitric acid. So it's 3 to 4, and then we want to know how many react with 40, right? So if it's 3 moles to 4 moles, then how many moles to 40, right? So this is my silver, this is my silver, this is my nitric acid, sorry, that's an H, HNO3, fix that a little bit here, HNO3, okay. So in order for this reaction to actually work, I need a mole ratio of 3 to 4. 3 to 4. Well, if I change my nitric acid, so like industrial chemistry, and I'm trying to think of companies you might know, Procter & Gamble, Bausch & Lomb, what's the other one there? Unilever. I don't know how to say that. Trying to think some other big companies. But even GE, big companies that use chemicals or make chemicals or need to do reactions for products they make. They're not using small amounts of these things, right? So 40 moles, that's a big number for us in these problems, but it's more realistic, honestly, on like an industrial level. So 3 moles to 4 moles. Well, what if we need to ramp this up and make a lot more silver nitrate? All right, so we would have to increase the moles of both reactants. So if we increase this number here to a 40, right, that's 10 times larger, then we're going to have to increase this as well proportionally to keep my 3 to 4 ratio. All right, I'm kind of repeating myself here. Did I just delete that? Well, I went, okay. Repeating myself, but I just want to make sure you understand the concept. All right, so you cross multiply, it's going to be 120 divided by 4x, right? 120 divided by 4, sorry, equals x. X equals 30 moles. There it is. That's for A. B, from the amount of nitric acid, so from 40 moles in part A, how many moles of silver nitrate will be produced, right? So instead of using 4 moles, which produces 3, we're going to use 40 moles. So how many moles will that produce? Again, if we increase this by a factor of 10, we're going to increase this by a factor. It's going to be the same answer, 30, but because it's the same ratio, but I'm going to set it up anyway because it's a different problem. So we have nitric acid and we have silver nitrate. So 4 to 3. 4 is to 3. And again, we're changing the 4 to a 40. 40 is to x. So it's very similar. All right. Sorry, sometimes, very similar. So again, here is my HNO3, HNO3. This is my silver nitrate, AgNO3, AgNO3. Cross multiply. Again, it's 120 divided by 4, so X is going to equal 30 moles again. Okay. C, from the amount of nitric acid, so again, we're using 40 moles. How many moles of water? Where am I? Water. So now, if 4 moles, right, 4 moles produces 2. So here's my HNO3. Here's my H2O. If 4 moles produces 2, then 40, again, we're using that same 40. Then how many moles of water will that produce? So if we increase this to 40, then we're going to get much more water out of this. Cross multiply, again, it's a factor of 10. So it's going to be 80 divided by 4, which equals 20. 20 moles, 20 moles of water is the answer. 20 moles of water. Right, again, we increase by a factor of 10. We increase this by a factor of 10 to keep the same proportion. Okay. Again, 40 moles. That's kind of redundant. How many moles of nitrogen monoxide will be produced? Right, I chopped that off, but nitrogen monoxide, so that's here. So now, same concept, except instead of 4 to 3 or 4 to 2, it's 4 to 1. So 4 to 1. Once again, here's my nitric. Here's my nitrogen monoxide. 40 HNO3, same thing. XNO. So if we increase this by a factor of 10, this increases, so X equals 10 moles. I know a lot of this stuff is sometimes redundant. Some of you are like, this is too easy, waste of time. The point is just, if you get it and you understand it and you just kind of practice like you do in math sometimes, then it becomes kind of like they say muscle memory, when you're shooting a basketball or running or lifting weights or whatever you're doing. You do it enough, your body, or throwing a baseball or whatever. You do something enough, your body just remembers how to do it. Same thing, right? Your brain will just remember how to do it. So anyways, that's 10 moles for D. Okay, there you go. Number 2. Yeah, we can just do that. Here we go. All right. So 2. How many moles of dinitrogen tetrahydride? So let's go back to, we'll use this color. So dinitrogen tetrahydride and 57 moles of nitrogen. So dinitrogen tetra means 4. That's this one. And then nitrogen is N2. So how many moles of this stuff if we want to make 57 of that? So I know 2 to 3, right? I know 2 moles of this will produce 3 moles of that. Question wants to know how many moles of this if I want to make 57 moles of N2. Right? So here's my N2H4. Here's my N2. N2H4. N2. So I know 2 makes 3. How many do I need? If I'm going to increase this 3 to 57, I'm going to have to increase this significantly. Cross multiply. 57 times 2 is what? 114 divided by 3 would equal X, right? So let me just do that real quick here. Divided by 3, 38. 38 moles would be the answer to A. Okay. How many moles of again, same thing. Or no, not the same thing. Tetraoxide. So now we're here. Dinitrogen tetraoxide to produce 57. So again, we're using the 57 moles of nitrogen, but now we're using this reactant, which is a 1 to 3. So it's the same setup, except 1 over 3 equals X over 57. Okay, again, so now this 1 is the N2O4, and this X is N2O4, and this is N2 again, N2 again. So it's the same, very similar question, except instead of this reactant, we're doing this reactant. Cross multiply, divide. It's going to be 57 divided by 3 ultimately here. 57 divided by 3, 19. Oh, yeah, should have known that. 19 moles. How many moles of water are produced from, again, same thing, 57 moles here, but now we don't care about the reactants. All we're worried about is the water and the nitrogen. So basically this question is saying, all right, if you change your reactants so that you're making 57 moles of N2, but you're also going to make more water. That's part of the deal. So how much water will you make, right? So we know if 3 moles of N2 are produced, 4 moles of water will be produced. Well, what if 57 moles of N2 are produced? How many moles of water will be produced, right? So we know 3 and 4 are going to be produced normally. Well, if we increase the reactants like we just talked about, and we get more N2, we're also going to get more water. How much more? Keep the proportion by setting this up. So 3x equals 57 times 4. 57 times 4 is 228. 228. You're going to divide that by 4. Oh, sorry. Wait a second. Did I type that in? Hold on, guys. I might have typed that in wrong. No. Yeah, this 57 times 4 is 228. Divide by 3 ultimately. Divide by 3. 76. 76 moles of water for letter C, 2C. All right, there we go. And all right. Oh, you know what? 3 is harder than I thought. Well, that's good. It's a good thing. Calculate the mass of aluminum oxide produced when 3.75 moles of aluminum burn in oxygen. Whoa. So I would be, I looked at some of the ones you guys submitted, but just kind of briefly, I didn't really look at this one closely. I'll definitely go over this tomorrow again when we have class, because I didn't think it was this tough, but this is tough. Again, my default phrase is, well, on the Regents, you would never be asked to do this, actually. So here's why. You have to write out the reaction and balance it. And actually, Tara, if you're watching this, you did this yesterday. So I'm going to put the reaction up top here, and then I'm going to show you the math down here. So really, you needed to understand it was A here. Let me make that a little bigger. Oops. All right, so make that a size 2. All right, so Al plus O2 yields Al2O3. This is a 2, this is a 4, and this is a 3. So the balancing turns out to be 4, 3, 2. So you had to do all this on your own. You had to say, all right, aluminum burns in oxygen. That's this. And I don't like that word. That's a little confusing. But this is a direct combination synthesis reaction. So to do this right, you would have to write this out and balance it, which is asking a lot from you guys. That's definitely an AP thing, not a Regents thing. So if you got this far, now what you would do is you would say, all right, here, let me. All right, so now mass, so now mass of aluminum. So we want to know the mass of this produced when 3.75 moles of aluminum react. Okay, so the first thing I'm going to do, I'm going to say 4, 2, 2. 3.75 to X. Again, I'm going to go over this again tomorrow, but here's my aluminum, here's my Al2O3, Al2O3. So I'm going to set a proportion up and say, all right, if 4 makes 2, 3.5 makes X. So it's going to be 3.5 times 2 divided by 4, right? So 3 times 2 is 6, 2 times 0.75, 1 point, so 7.5 divided by 4. 7.5 divided by 4, and that is 1.875 moles of Al2O3. So that's how many moles of Al2O3 this many moles of aluminum will produce. Okay, so now I'm going to erase this so I have room. Okay, so now what I'm going to do is what we did last week. Gram form of the mass of Al2O3. And I'm going to use a proportion to turn this number into grams, which is what they're asking. This is a really, really, really hard question. So each aluminum is 27. I'm drawing a blank right now. I believe it's 27 grams. Yeah, I know it's 27. But let me double check. So yeah, 27. All right. So 27. Here we go. So each aluminum is 27. So there's 2 of them. That's 54 grams. 3 oxygen, 16 each is 48 grams. So 54, 48, 2, 1, 102. That doesn't seem right. Yeah, okay. All right, so what that means is there's 102 grams in 1 mole. That's what that means. 102 grams in 1 mole. So now we take this number, 1.875 moles, how many grams is that equivalent to? So if the gram formula mass of this thing here is 102 grams per mole, if I have 1 mole, I have 102 grams. If I have 1.875 moles, it's going to be higher than 102. So 102 times 1.875, 102 times 1.875, and that is 191.25 grams. So if anybody got that, I would be very surprised, and don't be offended by that, but I haven't really shown one of these problems where you have to come up with the reaction on it on your own, balance it on your own, do the proportions for stoichiometry, solve for moles, then solve for grams. This is a crazy problem. So I don't know if you can tell my energy in my voice is kind of like, okay, this is silly. So what I should have done is I should have given you the reaction, at least made you balance it and then do the rest, but having to do all that is kind of wild here for you guys. But there it is. So if anyone got it, good for you, because that's great. If not, don't feel bad. You probably weren't supposed to. I hadn't really gone through anything like this. So again, this is more of an AP thing for sure. So there's that. All right. And I think that's it for this worksheet. That was it. All right. I'm going to stop this video. Let's see how long it was. Yeah. All right. I'm done. See you guys.